Okay, 2018 AD2. A particle moves along the x-axis with velocity given by, and we know they're giving us the velocity, right? We kind of figured that. This isn't our first day at the office. For time 0 to 3.5 inclusive, the particle is at position x equals -5 at t equals 0. Okay. Now, there's only so many different questions they can ask about particle motion. And they can't ask them all, but there's only so many things they can do. That's not going to be a big surprise, guys. Okay. So if they give you an initial position, they're probably going to ask us the position at a later time. They're probably going to ask us about distance traveled, or displacement, or something about acceleration. If something's speeding up and slowing down, or direction of travel, right? Which velocity would give us direction of travel? So there's not too many different things they can ask about particle motion, okay? But when they give us the function on a calculator problem, right away we're putting that in our calculator. Like yesterday, when they gave us a table, they're probably going to have to do a Riemann sum for something, right? That's how you'd find the antiderivative, okay? The approximate antiderivative. So, part A. Let's see, find the acceleration of the particle at time t equal 3. Well, you better be writing out a of 3 equals v prime of 3 and then equals, okay? You have to state what you're looking for and then go do it. Especially on a calculator problem, you're probably will be given a point for showing relationships between derivatives and other functions. Okay. After you have that in your calculator, what is that answer, by the way? Negative 2 point what? Like that? Okay, good. I mean, this should be pretty quick, right? We're typing stuff in the calculator. We know how to find derivatives. As that's a math 8 problem, right? Math 8, y1, x equals 3. Okay? Questions on that? Because it says that t equals 3. All right. Now, concluding statement, the acceleration of the particle at time t equals 3 is negative 2.118. Done. Okay, that's 1 point. 2, or part B, I mean, find the position. There we go. We kind of figured that was going to be one of the things they asked. Find the position of the particle at t equal 3. Well, if they give us the velocity equation, position is the antiderivative of velocity. And when in doubt, what do we use for these equations? Or for this problem? When in doubt, what do we use? FTC, fundamental theorem of calculus, right? Just write it out and then plug in what you know. They gave us the position at 0. We're finding the position at 3. V of t dt equals the position. I'm going to use S. You can use X, remember? And then position 0. Now they gave us the initial position, which is -5. Plug in -5, so that'll be +5. Subtract it over. And you get -5 plus the change. Equals the position at 3. And again, that's a calculator problem. -5 plus math 9. And when somebody has a good answer, let me know. -1.760. And we should be that quick on these calculations, guys. We should know where our calculator buttons are and how to use the calculator. All right, the position of the particle at time t equal 3 is -1.760. Is that the distance traveled? No. And then we understand that the antiderivative would be the displacement from 0 to 3. Okay? There's actually 3 points given to you guys for this. You get 1 point for your antiderivative setup. You get 1 point for using the initial condition. If you're not writing it down, you're not using it, and it has to be in like a appropriate setup. You can't just write down -5 somewhere. I used it. No, you're using it within the math problem, okay? And then you get 1 point for your answer.
If you don't have explanations for this one and the one before, will they count?
You should say what you're doing, because sometimes there will be. They won't give you full credit because you're not concluding. You're like, what does this number mean? What does this mean? Well, it's like all of us are like, well, it's acceleration. We said it's acceleration. Well, just make a quick statement. It takes 2 seconds. And it helps the reader out. And it really demonstrates that you know what you're doing. All right, here's a good one. Evaluate the antiderivative from 0 to 3.5 v of t dt, and evaluate the antiderivative of 0 to 3.5 absolute value v of t dt. Now, before I even go any further, what's the difference between those two besides the obvious absolute value? I mean, why are they different? Why are we asking us to evaluate two different things? What does one give us versus what does the other one give us?
The first one gives us displacement and the second one is total distance traveled.
That's exactly right, okay? So then the next part of the question says, interpret the meaning of each integral in the context of the problem. So then the first one would be the displacement of the particle from time 0 to 3.5. And then the second integral would be the total distance traveled from 0 to 3.5. Now, which number should be bigger? Total distance traveled. Could they be equal? Yeah, if you just driving or whatever in a positive motion and never come backwards, then go forwards, right? Your displacement will be a little bit different, but your total distance traveled will be way more. If you just go straight forwards, don't do anything else, they'll be equal. Okay, easy dubs they call it, right? This should be an easy part. You just type this in your calculator. 0 to 3.5 v of t dt equal sign. You should get a number. When somebody has it, give it to me. 2.843. We have confirmation on that? Okay. 0 to 3.5 of then absolute value v of t dt. Okay, so then conceptually, this number is bigger than this, so it kind of makes sense. So we figured this out. Now let's actually interpret the meaning. Okay, so 0 to 3.5 integral of v of t dt is the displacement of the particle over the time interval now we're going to be inclusive in our time interval because we are including 0 and 3.5. 0 to 3.5. Okay? Now, then we already said what the antiderivative, the absolute value is. That's the total distance traveled. So let's state it. Antiderivative 0 to 3.5, absolute value v of t dt is the total distance traveled by the particle over the time interval inclusive 0 to 3.5. That is 3 points, ladies and gentlemen. Not too bad, right? It's a lot of content knowledge that you're demonstrating. The specifics we've gone over. We've gone over all this before. You should be getting good at entering the stuff in your calculator. All right, part D. Let's keep going. A second particle, of course, there's always a second particle, moves along the x-axis with position given by, they're giving us a position function. That might mean they're going to ask us about either position or something else, or velocity or something, whatever. At what time are the two particles moving the same velocity? Okay. Well, what's the velocity of the second particle? That would be v sub 2 of t equals x prime sub 2 of t. You better be writing this relationship out. Equals, and what is it? 2t minus 1, right? Okay. Now, what are we looking for when their velocities are the same? You are looking for when v of t equals v sub 2 of t. You better write that down also. You're looking for when the two velocities are the same. How do we know that? They said it. So write it down. That's what you're looking for. Okay? But the other part is they're asking you to find the other velocity. Now guess what I'm doing? I'm putting this into my calculator as y2. I'm adjusting my window so it only shows the interval 0 to 3.5. And I'm looking for when the two lines cross, right? Okay, find the intersection of those two curves, y1 and y2. And then that occurs when t equals
1.570.
Everybody else get this? Okay, notice I'm not showing you guys how to do this in calculator right now because you should be able to do it. Make sure you're getting this number, please. Little concluding statement. The two particles are moving with the same velocity at t equals 1.570 or 571 if you're a rounder. I think that's very doable to get at least 5 points on this question, right? National average was 4 or under in 2018 on this question. Can you believe that? That's what it is. Okay, move on to the next question. 2017 AB5. No calculator. Put those things away then. Okay, let's have some fun. Question number 5, no calculator. Two particles move along the x-axis for the interval 0 to 8. The position of particle P is given by x sub P of t equals a natural log function. Okay, already I'm thinking they're probably going to ask about velocity. I'm probably going to find the derivative of that. I know how to find the derivative of natural log functions. Not too bad. Okay, while the velocity, oh here they go, they give us a velocity of a different one now. Particle Q at time t is given by v sub q of t equals not too bad polynomial, friendly function. Particle Q is at position x equals 5 at t equals 0. Mr. Bonley, they did not give us the position of particle P. Well, they gave us a position function. Just plug in an x value, and that's the position. Okay? For 0 to 8, when is particle P moving to the left? What does it mean to be moving to the left when we're talking particle motion? We're looking for when v of t is less than 0, right? I'm going to write that down because that's what I'm looking for, then go find it, okay? Now, particle P, they gave us a position. Well, we got to find the derivative. So v of t equals v sub p of t equals x prime sub p of t. Now, what's the derivative of the natural log function? Quick. 1 over stuff times derivative of stuff. 1 over the stuff would be, what, t squared minus 2t plus 10 times derivative of stuff would be the chain rule part. 2t minus 2, is that good? Like so? Okay, now, to know when something is moving to the left, you have to know where this particle is stopped. Where is a particle stopped? What's 0? I mean, in general, what is 0?
Velocity.
Velocity, yeah, that's what I'm looking for. Okay, and that would be true where it crosses the x-axis when it's 0. Okay, now we need to figure out, because this is definitely a number line problem, guys. You got to figure out where the velocity is 0 and then figure out what the velocity is between those zeros. Okay, so for a fraction, the fraction is 0 when the numerator is 0. So set the numerator equal to 0. Because we don't need to know when the velocity is undefined, do we? That'd be really helpful. And I'm sure, I think this isn't always positive, isn't it? I think so. Plus 10. Yeah, you're not going to subtract more than you're squaring something. So t equals 1 is a 0 for the velocity. Now let's check the velocity on either side of 1. Okay? Now, what's the velocity to the left of 1? So what's that? 0? Well, I can plug in 0. Negative on top divided by positive on bottom. That equals negative. So the velocity is negative to the left of 1. Great. Now what about to the right of 1? Plug in 2. 4 minus 2, that's positive. 2 squared is 4. Minus 2 times 2, it should make 0. Plus 10 makes positive. Okay. However, there's something else I need to add to my number line. Why?
It's not like that for every value, every other value just between 0 and 8.
Yeah, there's warning about 0 to 8. Technically, this function is the derivative. The velocity is negative from negative infinity to 1, right? They don't care about negative infinity to 1. They just care about from 0 to 8. So we better keep that in mind too, okay? Now, that does make sense though because we have to include 0 like this. So that's what our interval should look like because it is going to the left at 0. It's not going to the left at 1 because it is stopped. So this is what our interval should look like. Okay? Does that make sense? Quick concluding statement. Particle P is moving left on the time interval including 0, not including 1. All right, not too bad. You know, this is a little more student friendly, I should say, than 2021. Those are some rough questions, but you gotta be ready for them, and then don't get so distraught if they are difficult questions because a lot of them are intentionally made to be difficult. However, I might not get the full points on part A. Why is that? Because V sub P of T is less than 0. Okay, part B. This is looking a lot like a problem we've done before. 4, 0 to 8 inclusive. Find all the times t during which the two particles travel in the same direction. Well, we know the direction of travel for particle P. We don't know the direction of travel for particle Q. Well, let's figure it out. Good news is, though, we already have the equation. Velocity for Q is t squared minus 8t plus 15. This looks factorable. I'm figuring out where the velocity is 0. Would that be t? Negative 5, negative 3. Would that work? I think so. So at t equals 5, t equals 3. Let's pretend, imagination land here, if t equals 9, then what? exclude it because it's outside the interval. Okay? If we had t equal -2, exclude it, outside the interval 0 to 8. Okay, now let's set up our number line. Okay, I am going to include 0 now and 8. I'm not going to be tricked by that. And then I'm going to put 3 on here, and I'm going to put 5 on here. The only problem is it doesn't line up vertically kind of nicely with my other number line. I have to use my critical thinking skills now though. Okay, what's the velocity at say 2? Well, remember, plug in 2 into our factored form. That would be 2 minus 5 is negative, times 2 minus 3 is negative. Negative times negative is positive. Plug in 4. 4 minus 5 is negative. 4 minus 3 is positive. Negative times positive, negative. Plug in, say, 6. 6 minus 5 is positive. 6 minus 3, positive, positive. Now, we have to check over the interval. How about from 0 to 1? Particle P is going left. What's happening in particle Q? Going right. That's not the same. How about, okay, and if this helps you guys, you could do this. 0, 1, 3, 5, 8. Look at the signs. That's negative, positive, not the same. Okay? From 1 to 3. 1 to 3, that's positive. That's positive. So from 1 to 3, they're both going the same direction, right? From 3 to 5. 3 to 5, positive. 3 to 5, negative. From 5 to 8, positive. 5 to 8 here, positive. Same direction. Obviously, if they're both negative, it'd be the same direction too. Okay? So, let's see here. How are we going to write our intervals? Should we include 1 and 3? No, because that's when the particle is stopped. The particles are stopped. How about 5 to 8? Should we include 5? Don't include 5. Particle stopped. How about 8? Include 8. Okay, concluding statement. Particles P and Q are traveling in the same direction on the time intervals or over the time intervals. 1 to 3, 5 to 8, including 8, because velocity what? Same sign, both velocities. And we should say this, instead of saying this, let's do this. Instead of saying because velocity, let's be more specific. Let's say because the velocity of Q and the velocity of P have the same signs. That sounds better. Okay, let's keep it rolling. Part C. Part C, find the acceleration. Oh, we know how to find the acceleration of particle Q. That's just the derivative, right? At time t equal 2. Okay, that's one thing we got to do. Then the next thing is the particle speeding up or slowing down? Or neither at t equal 2? Explain your reasoning. Well, we know how to do this problem, guys. Analyze acceleration and velocity. Check the signs. If they're the same, speeding up. If they're opposite, slowing down. But first, we need acceleration. All right, acceleration equals the derivative of velocity. But for what particle though? Q. I better put Q in there then. Q. Okay, velocity of Q is that. The derivative is what? 2t minus 8? Therefore, the acceleration of Q at 2, is that -4? Plugging in a 2? Okay guys, what is the velocity of Q at 2? How do we know that? We've already made a graph of that, right? Or if you really want to, just plug in 2 into your velocity equation. So, positive. And then watch this. I'm not going to say what it is. I'm just going to say that it is greater than 0. Because I don't really need to know what it is. They didn't tell me to find the velocity at 2. They told me specifically to find the acceleration at 2. But I know the velocity at 2 is positive. Therefore, what's happening to particle Q at time t equal 2? Slowing down. Okay. You could say the speed is decreasing if you want to, the way they have it worded. Probably what we should say. The speed of particle Q is decreasing at time t equals 2 because a sub q of t and v sub q of t have opposite signs. All right, not too bad. Part D. Find the position. We knew that was going to happen. Why? Because they want to make sure we know the first fundamental theorem of calculus. Find the position of particle Q the first time it changes direction. Where does Q change directions the first time? Right here, right? Because the velocity equals 0 and the velocity changes signs. Okay? So we need to find the position at t equal 3. They gave us the position of Q at t equals 0. So our antiderivative then is antiderivative 0 to 3. Now, I could write v sub q, but I'm actually going to write out the expression for velocity for q because I actually have to do this by hand. T squared minus 8t plus 15, parentheses needed, dt equals position at 3 minus position at 0. Mr. Molly, I know the position at 0 is 5. Can I just write in 5 right here to save myself a step? Yes. Okay, I'm imagining 5 being right here, add it to the other side. So 5 plus antiderivative 0 to 3, t squared minus 8t plus 15 dt equals the position at 3. Now we actually have to do an antiderivative. That would be t cubed divided by 3, so 1/3 t cubed minus t squared divided by 2, 4t squared, plus 15t evaluated from 3 to 0. That equals our s of 3. Plug in our numbers. 5 plus 1/3, 3 cubed, minus 4, 3 squared, 15 times 3, minus 0. I like that one. Now guys, what I say, as long as it's in a as long as your answer is all numeric, you can leave it. But seriously, we can do a little bit of math. What's 3 cubed? We've done it 100 times. 27. 27 divided by 3. Minus 3 squared. Times 4. 15 times 3. Okay, 5 and 45 is 50. Minus 36 makes 14. 14 plus 9 23. Okay, the position of particle Q, the first time it changes directions, is 23. Boom, done. Not too bad of a problem, I think. Let's keep rocking and rolling. We have 14 minutes. Yeah, 14 minutes, right? Let's do this. See if we can get another one done in 14 minutes. Ready, set, go. 2016 AB2. This is calculator one. Get your calculator ready. 4, t greater than 0, a particle moving along the x-axis. The velocity of the particle at time t is given by some velocity function. They're always going to involve trig or natural logs or some crazy exponent when they're calculator problems. The particle is at position 2 at time t equal 4. They don't give us t equals 0 position. That could be interesting. At time t equal 4, is the particle speeding up or slowing down? Well, we know what to do. Find the velocity at 4 and find the acceleration at 4. So, we're finding the velocity at 4. Since it gave us the velocity function, that's all we need to write. That velocity function should already be in y1. You guys are quick typers. Get that in there. Go to your table, type in 4. And what do we get? 2.978. Okay, now the acceleration at 4 equals the velocity prime at 4. You better write this down, please, before you start typing your calculator. Write this down and then math 8. Find the answer. What is it? Okay, now what do we need to do sometimes? We need to state the obvious. What is 2.970 in terms of what we're looking for? Positive, greater than 0. And what is negative 1.164? Negative, less than 0. We have to state the obvious a little bit. That's fine. So, conclusion. The particle is slowing down. At t equal 4 because v of t and a of t, which is v prime of t, have opposite signs.
Do we have to write A of t equals v prime of t?
You could just write a of t is fine because we already have the relationship written right here. That should be sufficient. Okay? Find all times t on the interval 0 to 3 this time when the particle changes directions. You're looking for when the velocity equals 0 and changes signs, right? Go find that in the graph and only look at 0 to 3. And you're finding the root, right? You find the 0. Don't find one where it bounces. It's got to cross the axes, right? And what do you guys get?
2.707.
707? Okay. All right, concluding statement. The particle changes. My handwriting is just awesome. It's getting worse by the day. The particle changes directions at time T equal 2.707 because V of T equals 0 and V of T changes signs. It did not say it had to change moving left to right or right to left, just changing directions. That should be good enough. Part C. We have 10 minutes and we only have 2 parts left. Let's go. If you're not excited, you're a boring person. Just kidding. Find the position of the particle at time t equals 0. We knew they were going to ask about that. They always do. Antiderivative. 0 to what? 4. V of t, I'm writing it in because this is a calculator problem. I'm just writing V of t equals. Now this is where they changed it up a little bit. They are giving us the position at 4, and we got to find the initial position, right? At t equals 0. So, little bit different. We know that x equals 2 at t equals 4. So we got 2 minus s of 0. That's why I like to write out the full fundamental theorem of calculus and then solve for the unknown. Now what I'm going to do is I'm going to add s of 0 and subtract the integral to minus the change now. And then give me the answer when you got it.
Negative 3.814.
Now make sure you guys are getting it. You don't have to be as fast, but we should be able to get it, right? We're getting this problem done in under 10 minutes. You guys have 15 minutes per. That's fine. The particle is at position negative 3.815 at t equals 0. Now we probably should say x equals negative 3.815 at time t, t equals 0. Okay, part D. What are they asking us? Find the total distance. That's not too bad. Guess what? Almost every calculator problem, aren't they asking us to find the total distance? They have so far, haven't they? We should be good at this. And they said from 0 to 3. All right, 0 to 3, absolute value, v of t, dt. If you do not have this written down, and you just have an answer there, they have no idea what that is, you will not get any credit at all. Write down what you're doing, and then go do it. And what is it?
5.301.
So the particle traveled a total distance of 5.301 on the time, or I could say from, and you don't need your age, you can just cross it out, that's fine, from t equals 0 to t equals 3. Done. Now look at that. You guys only have one more FRQ to do for homework today. That's it. One of them. Oh, it's a table one also. So guess what they're going to have you guys do? Probably a Riemann sum. That's awesome. I'm glad you guys had this opportunity. Yes.